Hello everyone, welcome to a new episode of Tech Talk. So today we're going to continue looking at the instrumentation for a Next.js application. So just a quick kind of recap of what we discussed during the last video. It's around what OpenTelemetry is, what's Next.js, kind of the problem that we're trying to solve by instrumenting our application with OpenTelemetry. And also we went through a couple of core concepts around tracing and OpenTelemetry in general. Things like traces, package, spans, and that kind of stuff. So you want to kind of get deep into the concepts first before you continue with the second session. You can just go back and watch that initial video first, and then come back to this one and follow with the next steps. Okay, so what are we going to do today? Today we have the kind of the topic is the setup and doing some backend instrumentation. So as we discussed in the previous session, Next.js is a hybrid from two sections, that is the front end browser side and the client that is running on the server that is running on Node.js. So we're going to start by looking at how to set up our infrastructure or services that we're going to use on the backend, and how we can start instrumenting some of those pieces. Okay, so just going through the topics that you see on the right side. The first thing that we're going to do is set up Next.js. So Next.js will be a clean setup that we can follow from the Next.js documentation. And we're going to start our document compose file where we're going to add the application services and resources that we need for OpenTelemetry as well. We're going to discuss a little bit about collector data sources. And at the end of this session, we will start with the instrumentation piece, that is starting with a Node.js SDK client, the auto instrumentation, and what's the difference between doing that versus a manual instrumentation. So let's begin. So before we start kind of diving into the code and some of the concepts, I want to kind of explain or go through the question of what are we building. So we are building an instrumented to-do application, Next.js application. So this is going to be pretty straightforward, just creating items on a database, checking them as completed, and each of the items will have like complete status and a create date. That's everything that we're going to be doing on that day. So the complexity of this tutorial is around instrumentation and not so about what kind of features are we building in the application. We're going to be using TypeScript for most of the part. There will be a couple of sections we will be using JS, but it will be pretty small sections. We're going to be using Postgres database to connect to save this information about the to-do list and that kind of stuff. And to help us with that, we're going to use Prisma. So Prisma is an ORM node package that is basically generates the types and the interfaces to the database based on the schema. So part of this video tutorial is going to focus on that. Okay, now that we kind of are on the same page of what we're building, let's continue to some coding. Okay, finally, so I'm going to stop sharing the presentation, and let's start looking at the browser first, because that's the next interesting thing that we need to check, right? So the first thing that we're going to be running is from the Next.js documentation. We're going to create a Next.js app based on the TypeScript template. So this means that we're going to have the basic TypeScript implementation around our Next.js app. And then, so yeah, that's kind of the first step. If I show you guys the code or the terminal first, what I ran was pretty much just npx create app latest, and when I got asked by the name, I just selected demo. So right now in this terminal, I'm already within that folder and with everything ready to start, but it's just the bare bones, the basic stuff that you can find in the Next.js documentation. So I haven't added nothing yet. Okay, next step that we want to check, let me go back to the browser, is how we need to start Dockerizing our Next.js application. So to start, we're going to be using something that is already provided by the Next.js or Vercel in this case. If you go to Next.js documentation and look for deployment, and so in a section you'll find the Docker image implementation. And if you go to this repo with Docker, you will basically find the whole example how you can Dockerize a Next.js application. And if you go to Docker file, you can see everything that you need, all of the steps. So what I did, or what I want to do, is I'm going to just copy everything, and we want to bring that into our app. So I'm going to be moving to the code editor now. So we have our demo app running. We can start writing our code and that kind of stuff. So the first thing that I'm going to do is I'm going to create a Docker file. I'm going to paste everything that I got from GitHub or from that example, and we're going to be adding a couple of things. Yeah, so let me just go back to the editor. We're going to be adding two things to this to make the changes work. So the first thing is adding our instrumentation script. We're going to comment that for the moment, and copying the node modules from the dependency image. So those two things is something that we can just comment for the moment. We don't need them yet. Okay, so that's kind of the first step. Sorry, I was showing you I was looking at the wrong stuff. So we're going to be doing these two steps. First is copying, moving an instrumentation file, and the second one is copying the node modules from the dependency step. So this Docker file has three steps. The first one is dependencies, where you run the install, that kind of stuff. The second one is just to run the build, and the third one is the one that executes the application, the standalone application. So there's another step that we need to follow in order to keep to have this Next.js implementation working with Docker, and is we need to change the Next.js file to output, to standalone. Okay. So these are the two things required to Dockerize an Next.js application: the Docker file and changing the next config to be the output be standalone. So this is the only thing that we need. Okay, so now I'm going to start writing the Docker compose file. As we're going to be using multiple services, we'll be using two services for our app. That would be the application and the Postgres instance. And then for the OpenTelemetry, we'll be using two other services that I'm going to explain you in a bit. We want to start everything by using Docker Compose instead of just having the images like spread out. So, and this is kind of the standard way of working with Dockerized, local Dockerized applications. Okay, so for that, I'm going to kind of copy some stuff that I have prepared in the repository for you. Please look away for a second. I'm just going to copy those things, and I'm going to display it right away. Okay. So the changes that I have here is just setting the version for Docker Compose, setting a specific default network that is going to be called Next.js Hotel, and then two services. The application service that is going to be pointing to our Docker image that we just created, and the second service that is going to be using an image from Postgres. So we have the Postgres image, we have our Dockerized application for Next.js, and this is pretty much what we need for the moment. We can even forget about the environment stuff at the moment. We don't need that yet. And we need to bind the port 3000 because Next.js uses that port to spin up the application. Okay, next thing is we have our Dockerized images, Docker Compose. We have our Dockerized Node.js application, Next.js application. So what we can do is test it. So from the root repo, I'm just going to run Docker Compose build. And service app depends on the file. Okay. So let's remove the auto collector dependency for the moment, as we don't have it yet. And we can start the build. So these two services, the application is going to be divided into two things: the application services and the Open Telemetry services. The application service, basically everything that your app will need to work. Like if you're building something that includes, I don't know, a cache layer with Redis or Open Elasticsearch or things like that, that would be an application service. And for things that include Open Telemetry, we'll have another different section of resources I'm going to explain later. Okay, so we have our build ready. We can run it. Docker compose up. Okay, everything looks pretty good. So let's go back to the browser to see if this is working. So from the browser window, I'm just going to go to localhost 3000, and I see the Next.js running, Next.js application running, right? So this looks correct. Okay, let's go back to the code. Actually, let's go back to the presentation. Okay, so we did our first part, that is setting up Next.js, Dockerizing the application, and including the Postgres service. We haven't connected these two yet. We're going to do that after we have the full setup, so we can include Postgres and Prisma. Actually, maybe we can do that. Yeah, I guess we can start with that. I want to change the pace a little bit. I'm going to just focus on setting up our application entirely, have that available, and then we can instrument it later on. Okay. Okay, let's go back to the code base. Okay, I have my editor right here. Okay, so I'm going to connect the both services, the Postgres image with the application, and for that I'm going to use my ORM. So I'm going to stop the Docker Compose up, and I'm going to install Prisma. What is the name? Prisma. Okay, save dev. So this will be a dev dependency. Next thing is initializing Prisma npx Prisma init. This is going to do two things. It's going to create a Prisma folder with a base schema, and it's going to create an M file with the database URL connection. So we can change this to with the things that we have described in our Postgres, where the user and password is just Postgres. So we can do that here, Postgres, and then the database, let's call it to do. Just like that, to do, I don't know, to do or demo. Okay, you can start with that, and then what we can do next is we have to create something on the schema side. So on the schema, let's create a model that is going to be called to do. This will represent our table. So we just use autopilot, and we can say the ID, it's an integer as default, auto increment. We can have a title, completed, boolean. We don't need a user ID, so let's just do create that, and we do default now. Okay, so with this we are basically telling Prisma we need a table with these specific columns, and then by running Prisma generate, that will be the next command. Everything will be generated for both the backend service, and I think no, actually it will just generate the client service, the client services and the types. So if we go and do npx prisma generate, it will say, okay, you can use these two lines to connect to the database now. You don't have to do anything else. So we can just copy this thing and we can save it here for the moment. Okay, next thing would be actually generating the Prisma migrations and compose and creating the tables in the database. So for that, I'm going to use docker compose up, so we have the database available. And the next thing that I'm going to do is I'm going to be using a separate terminal to do the rest of the stuff. Okay, to run the migrations, we have to run execute npx prisma migrate dev. Okay, seems that something is wrong, and what happened is that the host is not Postgres, it's localhost, because Postgres is just for the internal Docker compose network. Enter name of a migration, init. Okay, so now if we will look at Postgres, we'll see that the table exists and that kind of stuff. This is not a kind of Postgres Prisma tutorial, but so I'm not going to do that. Okay, so next thing would be, let's create a service that pulls data from Postgres and prints that into the client. So let's start by creating a services folder and create a service that is going to be called to-do service ts. We copy our stuff that comes from the Prisma client. We have these two things, and we're going to use this to create our service. So I'm just going to create, or let's create the CRUD methods, the basic CRUD methods. That would be create, remove, update, and delete. So we can just do to-do service equals, and then we create a function. And this function is going to return an object with the information we need, the functions we need. So we do get all, or let's do find all, and we return Prisma to do. So Prisma knows everything because we have our schema, and then we can do find many, and then we can do find one. Autopilot is basically completing everything for us. Find unique. So we have the view side. We need to do the create, return Prisma, create data. We don't want to use any here, so I'm going to use Prisma, and Prisma knows all of the types as well. So we can do Prisma to do input, create input. Okay, so this is going to specify, okay, you need the title, the complete boolean, and the created at. Next thing, update, autopilot for the win, right? So we have the ID number, the data that is set to do update input, and we have our well, basically we really need remove. Let's do remove. ID number. Let's see if okay. Autopilot has everything ready for us. So we have everything that we need for our CRUD service. We just need to test it to see if it's working, right? Okay, so Next.js has two different ways of interacting with the browser client. One of them is when it renders the React code by SSR and then doing the hydration process on the browser. And the other way is by exposing API endpoints that can be executed from the front end. These endpoints are RESTful endpoints, and it's usually kind of handful, or it can work as a proxy to other backend services. So this can kind of work as your aggregation layer. Okay, so I'm going to use this API endpoint. It works pretty, if you're familiar with serverless, it's pretty much, it's quite the same, similar to it, but it's like writing a controller for an Express for an express route. That could be, I think that's the best example. The best way to explain it. Okay, so we have our handler. I'm just going to change this because I don't like the way it starts. Okay, we have our handler. As an express route controller, it receives request and response, and we want to use our to-do service here. So we can do const to-do list equals await, and we're going to require async here, to-do service dot find all, and then we can return the JSON just the to-do list. Now Type3 is going to complain because it requires to specify what type of data this handler can return, and we're just saying that the type of data is name string. So let's change this to be an array of to-dos. Okay, so everything is fine. We're supposed to have everything connected and working as expected, so we can just run our application and test that. Okay, so what I'm going to do in this case, I'm going to show you Docker for a second. I have the demo application running, and I'm going to kill the app because I want to have a local environment running, not the containerized version. And both are going to be using the same port, so I'm just going to kill the app. That means that if I go back to the VS Code and I run npm run dev, it should allow it for to start. Okay, so let's go to the browser. In the browser window, we can refresh. This still works as expected. The thing is that we now have hot reload. So I'm just going to go to change the index to have something different. Hotel demo. As you can see, it changed in the browser, right? Let's go to an API route. API routes are defined by API and something, the name of the file. So the name of the file is hello. So if we do hello, we see that our backend or a backend side or Node.js side of the app, Next.js app, is connected to Postgres. Why? Because it's returning an empty array. So an empty array, it means that there's no to-do entries in the database. It's just empty. If the database connection didn't work, we will get an error or something like that. But we didn't get that, right? And even if we go back to the code base, we see a terminal, we see everything working fine. Nothing has changed. Okay, let's continue. So we have, let's think about the stuff that we have added. We have added our initial Next.js application boilerplate code. We added a Postgres connection using Prisma, the ORM. We have our to-do tables on the database. We have our first API endpoint that connects to the database and retrieves the to-do list. We haven't changed anything regarding the React code yet. So this session will mainly be focused on backend, so that's the thing. So I think we are ready for the next step to start doing some instrumentation for the backend. We are going to instrument the pieces that we have. So let's just keep clear. We have two things. We have an API endpoint that is working, a React application that is producing some SSR code, and a Postgres connection that is retrieving information from the to-do table. So we have those three things, right? Sorry. Let's instrument those. And by that, we need to go back to the presentation to look at some concepts. Okay, boring part for a second, and then we can go back to the code. As I mentioned, we're going to talk about two things, collector and data stores. They are both kind of related, so you might hear me talk about the data stores where I'm talking to collector, but just bear with me. Everything, I suppose, it has to make sense at some point. Okay, let's start with the collector. Collector is a middleware, or it's like an interface, it's a service that basically receives, processes, and exports data. So this is kind of the core concept that you find in the OpenTelemetry website. And on each of these steps, receive, process, and export, it has a plugin interface that you can include different ways of doing these three things. So you can modify how the collector is going to receive the data in different formats and things like that, how it's going to process it, so how it's going to manipulate it and probably do some connections, something like that, and how it's going to be exported. But in the end, the idea of this collector is to be something that is vendor agnostic. This means that it's not proprietary by Datadog or OpenSearch or any other types of vendors that might want to have their own standards in their own way of handling things. So the collector is basically a predefined standard that everyone can use, and the vendors can create plugins for the collector to accommodate to their data stores or their standards. So this is kind of the middle ground where so you don't have to kind of understand all of the different possibilities for each of the vendors. You just use one standard and that's it. And I grabbed this image from the website. What you can see here is that it has the three pieces. It has the receiver on the left side. It has all of the processors in the middle, how it's going to be patched, process, attributes, filter, and where it's going to be exported, how it's going to be exported. It can be to Prometheus, that is another data store tool, or Jaeger, and each of these, well, let's talk about data stores in the next slide. Okay, data stores are pretty much just services that save the data, the traces, and all of the telemetry data that you send. And they usually have different purposes and have different kind of ways of handling that data, but it's pretty much you can use it to visualize, filter, and manipulate traces and spans. So a great example of this that we're going to be using for this demo is Jaeger. Jaeger has a pretty basic implementation for displaying traces and spans, and you can search by name, by operation, service name, all of that kind of stuff. So it just it's a visualizer for the tracing stuff. Okay, now that we know this, we can go back to the code. Okay. So we need to add these two things. The to open telemetry services that we need is a collector and a data store. The collector is going to be the open telemetry collector as a standard, and the data store is going to be Jaeger. So how do we do that? We just go back. We need to go back to our Docker Compose file. Okay, I'm just going to grab that from the other repo that I have ready for you guys, so I don't have to type everything because that's all quite extensive. Give me a second. Just 1 second. Okay. This is the open telemetry services, or collector, the open telemetry collector, and Jaeger. So as you can see, for including the Jaeger instance is pretty straightforward. You just need the image and the port that you want to be exposing. And the auto collector, it requires a little bit more stuff to expose and to configure. So it requires that to send a configuration. I think you can use running as it is, but in the terms of selecting the specific exporter and processor and receiver, you have to specify this configuration to have it connected to the data store, in this case Jaeger. So we need to create that configuration. That configuration is going to be a part of the volume that we're going to be sending to the image, and then we're going to be running the entry point with a specific configuration. And there's a couple of ports that we need to expose. There's a gRPC protocol port where you can send traces through gRPC, and that's actually what we're going to be using for the Node.js section. And then there's an HTTP port where you can send traces and telemetry data through HTTP, and this is the one that we're going to be using for the frontend. And I think those two are things that you will use for the exporters and that other stuff. Okay, so let's add one dependency to our app. So we don't only need Postgres anymore. We need the hotel collector. So we need the hotel collector and Postgres, and we also need this some of the environment variables. So we can say that where are we going to be exporting the data, and what service name is our application going to have. We need to add this for both the Docker version of our app and for the environment file. So on the environment file will have something like this. Okay. So what's the next step? So we just added the services. We need to start adding the instrumentation code. So just to validate that everything is working as expected, I'm going to do docker build and docker up again, so we can see the Jaeger instance running. Docker compose build, and we can kill this. And we wait. So this shouldn't take that long. It's just a couple of new services, and both are images. Actually, we missed one point. We missed the configuration file that I'm going to be adding as soon as this, actually while this completes. So I'm going to copy that as well from the repo that I have ready for you guys. Copy, and I'm going to explain that later. Paste. Okay, so under the config folder, we're going to have the hotel collector configuration, and this is going to have the three pieces that are described within a collector. That is the receivers, exporters, and processors. So receivers is what protocols and what is going to be used to get the data into the collector. In this case, we're telling, okay, we need to open the gRPC endpoint, and we need to open the HTTP endpoint, and we also need some coarse configuration to being able to access the collector from the browser side. Okay, and then we have the exporters. Okay, we are going to be exporting our data to Jaeger. We can use the service name here because this is going to be within the same Docker Compose local network when we execute it. And we are saying that we want the telemetry data to be batched in a time mode of 100 milliseconds. And then we can glue everything together at the bottom, saying, okay, this is my receiver, this is my processor, and this is my exporter. Okay, so this is the basic configuration for the OpenTelemetry instance, OpenTelemetry collector instance using Jaeger. Okay, so we have our file ready. We should be able to run Docker compose up. And I hope this doesn't blow in our head, but okay. Let's go back to the browser for a second. And we can open local hosts and the Jaeger UI endpoint. And there you go. We have Jaeger running. So yeah, we know that we have Jaeger running. How do we know if the collector is running? Okay, we can add some instrumentation data to validate that piece is running as well. So let's do that. I'm going to go back to the VS Code, and we are going to be adding some code again. So at the beginning, when we were creating the Docker file, I told you that we needed two things. So we need those two things back again. We need the instrumentation script and the node modules. So let's create this. Instrumentation script. Once again, oops, I lost my forward. I don't know why my trackpad is not working anymore. Okay, I guess I'm going to try using the one from the laptop just to finalize this video. Okay, let's go to, I'm going to copy something, the instrumentation file from the repo that I have for you, and I'm going to bring that to the demo repo that we have now. What is it? Okay, so we're going to create that file under utils, so we need to create one folder called utils, and then we can do we can paste it here. Actually, I'm just going to create it in instrumentation.js, and we can paste the code. Okay, so what's going on here? Why did I create a JavaScript file when we are using we're supposed to be using TypeScript? So this file is not going to be part of the bundle. We want it to be included and required as part of the application, but not as part of the bundle, because this is just for the backend. We don't need it for the front end, and also it would be because we want to require this file before anything happens. So as the auto instrumentation process for OpenTelemetry adds some or tweaks or changes some of the things that how the packages work, we want this to be the first thing. So once this kind of the tweaks are already there, already prepared, once we start importing the rest of the dependencies like HTTP, like gRPC stuff, or Prisma stuff. So what is going on here? We have first we are loading our M file. Our M file will have the information for .l service that we're going to be using, and where do we want to send the data to. Where's the instrumentation file? Okay, here it is. We're going to be using the Node SDK. So the Node SDK has already a wrapper with all of the things that we need, the provider and that kind of stuff. We just need to spin it up with the basic configuration, and that will be it. One of the things that we need is the OpenTelemetry exporter, trace exporter. So this is going the connector or the interface that is going to be connecting to the OpenTelemetry collector instance. So this is what the one that is going to make that connection. And then we have two types of instrumentations. We have the auto instrumentation for Node and the Prisma instrumentation. So the instrumentation for Node, it will basically tweak some of the core packages, and it's going to add instrumentation to it automatically without us having to add code or something like that. So things like the HTTP is going to be tweaked to, for every outgoing request, we are going to get some telemetry info, and for every incoming request as well. So everything that comes from the clients, we're going to get a span and trace. And things like database connections to MongoDB or some connectors or gRPC requests are going to be also intercepted by the auto instrumentation, and we're going to get data from them. So we don't need to do like any code on that part. The other instrumentation that we're adding is the Prisma. So Prisma has its own packages and its own way to do the instrumentation. That's why we are adding an instance for that. Okay, so we just copy paste the file. We need to install all of the dependencies. Okay, let me do that. Okay, I don't know what happened to my trackpad, but here we go. Let's see if this works. Okay, awesome. So we just need to do npm install, and then we can paste everything. Now, how are you going to be adding this instrumentation file to Next.js and making it run for both the Dockerized production version and the development version? So we need to go to our package JSON file. We see that we have a couple of scripts already defined here. The first one that we're going to update is the development one. So we need to do node options. This is kind of passing arguments to the Next.js script for node. We can do -r and the name of our file. So it would be utils instrumentation.js. And for start, we need to go to the Docker file, and we don't need node server. We don't want to do the node server anymore. So let's just do. Actually, we can just copy this, and then we can do npm start, and then we can go back to our package file and update this. So we need node server, but we can do I think is dash require, and we're going to be looking for a file in the same folder. Okay, give me a second. Just going to verify those things that are real. Let's go back to the demo. Okay, we don't need the equal sign. So let's test this. Let's go to our terminal and run npm run dev. Cool, looks good. Let's go to the browser side now. We see Jaeger, we see this angry, I don't know what that is, angry animal. We refresh, we see nothing. Let's go here, we refresh, we see the app, we refresh, we see internal server. What's going on? Let's go back to the code. Okay, there's one thing that I missed. But before that, let's just see if Jaeger has some information. It doesn't have any information yet. Okay. Let's go back to the code and debug what is going on. I think I know what's going on. Okay, so the schema for Prisma, this is something that is not, it's just in beta. So we need to add the flag. I think it's just preview features equals array tracing. Okay, and I think what we need to do, maybe we can just run the npx prisma generate again. So we come here, we run npx prisma generate. Cool, let's try it again. Okay, I see what's going on. We don't have I need to kill the app again. Okay, 300. Okay, let's go. Okay, the app is working, but the API input, no, it's not. We don't have any Jaeger information yet. Let's see the error. Runtime Prisma client. Did we miss something? Let's look at the package JSON. Prisma client, Prisma. Yep, I think we missed the Prisma instrumentation. Yeah, because this is not the right one. Okay, let's go to the package. And then we need to add the right dependency. This should be the right dependency. And then we have to change the dependency in the file. Let's go to the instrumentation file. We can update this. Oops. Prisma. Okay, let's do npm install first. Let's go back to the package and we remove the faulty dependency, and then we can do npm install. Okay, let's go back to this Prisma instrumentation. Okay, that should be the one. Okay, let's start it again. Let's go back to the browser. We see the app. We don't see anything here. We don't get anything from Jaeger yet. Okay, let's debug that issue. So we can close this video out. Prisma instrumentation. Hot reload server. We can go to the Docker compose file. M file. Is this good? Hotel. Backend. Instrumentation. Let's see if I'm going to just print the process to see what we get here. And we can restart this thing. Hotel collector, database. Okay, we have this Prisma tracing. Can get rid of this. Okay, let's try to. I'm going to remove the Prisma instrumentation for the moment and run it again. What we can do now is just go to the checklist to from Open Telemetry, Open Tele Node.js troubleshooting. You're going to find this documentation, and what you can do is just enable the debugger so you can see more information. So I'm going to go back to the code, and I'm going to add a debugger. Const require. Okay, let's start this over again. Okay, we see some information here, and we get no resolution for target, hotel collector, and then this URL. So maybe what we can do here at the moment is just change this for localhost. Let's try again. Awesome. So let's go back to Prisma, to Jaeger. I'm going to share the browser again. I'm going to execute a reload here. Okay, the API input is not working, but that's something that we can check after that. And then if I refresh the Jaeger instance, I can see that we have some traces. So these traces are going to be mostly for incoming traffic. So this is HTTP host. We get the HTTP host. Okay, let's go back and explain some of the concepts. We have a trace. This is our all traces, and every span that it's within a trace has a service name, and services can be looked here. So if we go into a trace, we'll find spans, So this trace only has one span that's coming from the backend, app backend. So if I open this, and I can see that every span has a list of attributes, and these attributes are based on the different specification for that HTTP get incoming request. So we get that hosts, method, status code, we get the library that we're using, for instance, instrumentation HTTP, we get the user agent, and like basically everything that it's within that incoming HTTP request. Okay, so we have instrumented our app, just the incoming requests. To finalize, I'm just going to want to fix the Prisma stuff and understand why this is not working, and then we can just close this video for the next one to start with the manual instrumentation, and the front-end stuff. Okay, so let's just go back to the demo. I'm going to share my code once more. I'm going to go to the instrumentation file, and I'm going to re-enable the Prisma, new Prisma instrumentation. And I'm going to reset the server. Okay, let's try again. I'm going to refresh this. Still not getting data. Do we see some? Maybe we can see if we have extra spans. Okay, so we get something from Prisma. So as you can see, by just adding the auto instrumentation from Prisma, some of these traces will show multiple spans, and these are going to be related to the Prisma operations. So we have a span that is the find many, as you can see, and then we have one for engine. This is internal. The connection, it basically just telling us, okay, this is a Postgres, because Prisma can be connected to a different. And then we have even the query. So we have the select public, everything, the query that is running on the database. And I guess this should be the response. Okay, this is just something to get more details. So yeah, as you can see, this instrumentation is displaying a lot more information from the Prisma side to identify what is going on. So if you're debugging an error, you can see, okay, what is the in this specific request, what was the query that was triggered. You don't even need to kind of understand if it's Postgres or whatever. It's just you can grab the query from here. Let me just see why actually it is working. Hey, I see the array. So it is working. Okay, so we have our both of our sides working. We have Jaeger installed, Jaeger running. We have our application backend connected to the open telemetry collector, and then we can display traces with not only the node basic instrumentation but also the Prisma one. So everything that you see here today is going to be part of the GitHub repo that I showed you last session. Let me show it again actually. So this is the repository. I'm going to be updating this repo on everything that is happening with on each of these sessions, and probably a couple of sessions in advance. But the idea is that we can go over the changes on these specific videos. And then if you have any questions for me or anything you want to discuss, you can find me at _io. You can ping me. I have the DMs open. Yeah, so thank you. I hope you enjoyed this video and it was helpful for you guys, and see you in the next one. Cheers.